Hi guys, welcome to my channel. In this video we are going to be analyzing a 2D frame in Autodesk Robot Structural Analysis. I got this 2D frame from Aslam Kasimali book. It's a 2D frame with columns and beams. The three support are fixed. We are going to use structural analysis robot, Autodesk Robot, to analyze this 2D frame. My robot structural analysis is opened. To do this, we need to start to select this 2D frame. To select 2D frame is opening. It's ready to be used now. We are going to start by setting up the grid line. As you can see, the grid line are going to pass through the nodes like A, B, C, D, E, F, G, I, J, H, I. Sorry. Let's setting up our grid lines. Click this button. On the x-axis, we do have the first dimension is 12, and 8 and 12 is 8 and 12. If I go back here, you will see this is 8 and 12. That gives you 20. And on the z-axis, we do have 8. I'll put 2 repeat and then 8 meters. There you go. If I click apply, we have our grid line set up. We now need to define the members, the cross section of the members, and adding up the members to connect these different nodes. In this case, we are going to select, I will select the RC beam, this material, RC beam. I already defined, previously defined a section 230 by 450. If it's not yet defined, you can just go here. Can come here and define it here. RC beam materials, and put in the dimension here and click add. But for now, we already got a section, so we don't need to add anything. For now, I'm going to select the 230 by 450. 230 by 450. Let's drag this thing aside. First beam here. Now we must select the RC column. I already got it defined, 230 by 700 RC column, and we'll start it here. Fine. We are, our structure is already being modeled. We need to define now the support condition. As you can see, all the supports are fixed. Let's add the support. I'm going to select fix. Close. We have assigned all the support. Now we need to define the load types. In this case, I mean the dead load, the live load, the wing loading. But for this case, we are only going to consider two types of load: the dead load and and the live loads. Dead load, add, and live load, add. Close, we're done. Let's define the load. The load type, we only got two loads. We are not going to input any dead load because this will be considered, this will be only be the self weight of the members. So Autodesk will calculate them automatically based on the cross section and the materials we defined earlier. So I'm only going to assign the live load. As you can see, here is a live load, and also on top here it shows you live load. There's no point load here. There's no node. There's no loading applied at the node. So we only have the uniformly distributed load we apply in this case here. So our selected bars, they define on the z-axis is -10 for -10. And the lower beam we do have -20. Now we can display our loading. Now we are ready for calculation, for analysis. So we already set up all our loading, the members, the support. We're ready to calculate now, to analyze the structure. We click this button here, calculations, calculation complete. You can now see the result. Let's go on top here, click here, result. Result. Okay. Let's select our load case because it's we did the application just calculate only individual load. I mean in your load case, the load 1 and then the live load. Let's go back now to the model because I need to apply a load combinations. I need to apply the load combination. Start. I need to apply. Let's define the load combination here. I should have done that earlier before the calculation. I'm going to define it. Load case 1. No problem. Load case 1. I will select dead load and coefficient 1.2. And the second load case is it's live load and the coefficient is 1.6. Yes, I'll set up this our load case. Yes, our load case definition here done. This basically means that all the dead load will be multiplied by 1.2 and all the live load will be multiplied by 1.6. And the two combine, and they would then be added up to form out the load applied to the structures. So if I go back to my frame, yes, our frame here. If I click here on the load case 1, you can see here the value have changed. The value have changed here now. If I go back to live load, you will see this is what we applied. If I go to dead load, you won't see because it's the self weight of weight of the structure, but it's not 0. is not, that value is not 0. So this is what we're interested in. We're interested in load case 1, because this is what gave us the maximum value, which is also called the ultimate load on the frame. So now we can redo our calculation. This is our calculation. Now we can go back to the result to get the proper result. Here we are, and define the parameters. I need to see this just to set up how the bending moment and shear force will look like. Let's go back here. For now, this is by clicking this one, I will see the axial forces. If I click here, I will see the shear forces. And this at the moment, we are going to start on the moment. Let's click it. Let's select our load case. There we go. Bending moment. Apply. Parameter, I need to see the test. Load. Here is our the bending moment. Yeah, the bending moment on our frame. Yeah, the bending moment, and then we can see also now the shear force. Here are the shear forces on the structure. For load case 1, you can see now the axial forces. Here are the axial forces for load case 1, which is only what we consider. We're only considering load case 1 on this case. And then you can also go back, see the reaction. Let's first can also see the reaction, or the 3 reaction moment on the X or Z and the moment. Here we go. Description. We got Fx, Fz, and the moment. And the same thing apply here. Here are the reactions. And we can also have the full analysis result on the table. Here we do have forces. We can get these forces, we can get the displacement, we can get the reactions. And then now let's just go to the forces here. Here you have the full force on each members. As you can see here, it gave you, like for let's say for instance, for bar number 1, node 1, load case 1, we have this value. We have the Fx, we got these are axial forces, we got the shear and the bending moment at each point on the element. And for on this one, it gives you for all the 3 load cases. Yeah, the 3, like load case 1, load case 2, load case 3. So that's it. And from now, having all this result, you can now design your beam or column based on the local code. You can also do that here in Autodesk Robot. Maybe on our next video, we are going to look at such thing. Thank you for watching. Goodbye.